Hi, I'm Damien Alpazar with the Sphere Productions. I'm here to test out the new DataBrick NLE CPU system. Currently we use a 16-core unit. We built it and developed it ourselves in-house, and we're going to test out a Maya scene, a simple Maya scene. First trying out with mental ray, and then we're going to try out the Tesla card that comes in this unit with the V-Ray renderer and see the differences, both the mental ray renderer and the V-Ray renderer, compare the two, and ultimately compare this computer unit with the computer units that we have currently in-house. One of the first things we noticed upon opening the scene is that Maya itself launched extremely fast. I mean, it took less than a second or so to open up. We've been navigating around. I've been checking out to see how quickly the windows and other things interact. We even did a particle system earlier that worked out really well. It seems to handle a lot of computational power. This scene isn't supremely high as far as faces and vertices. It's only, we're talking about 2,300,000 polygons. So not really huge as far as scenes are concerned, but we've tested it out with some bigger scenes and it moves around fairly quickly. For the purpose of this demonstration though, we wanted to make something that's very, very simple, that we can make comparable shaders between the Maya shaders, mental ray shaders, and the V-Ray shaders, and render it quickly just to see what one frame would take, and then obviously make the comparison in that. Here we're taking a quick look at the render settings. We have ray tracing obviously turned on, and we have global illumination turned on. There are some acoustics that are being calculated because this figurine over here is glass. We do have final gathering turned on as well, turned up the accuracy to 200. It's probably, we could obviously go higher. The point density, actually, I'm going to go ahead and turn that to 1, just so that we have a better reference that we were doing lower test renders earlier. So we turned the point density up to 1, point interpolation at 20, final gather map. Now, obviously, these settings will be different with different scenes and different machines, but we wanted to test this general setting against our computers and at the Sphere. We also have 64 samples per pixel. The Gaussian, we could go up to Mitchell, but we're going to test it out on Gaussian for now. And that basically gives you an understanding of what our common presets are. And we're going to generally match these presets with the V-Ray renderer as well. Currently the image is 1280 by 1991. It's more of a portrait image. This is, again, just for rendering purposes, for testing purposes. We're about 3/4 of the way through the render right now. As you can see here, the CPU is at 100%. One of the things that was up there, it comes back here. And you can see we've got a lot of reflections and refractions going on. The Jade shader is highly reflective as well. Plus we have the brushed metal down here. We'll get a chance to look at that in a better resolution here in a little bit. But right now the key thing is that we're only using the 7 gigs of memory. We don't have a lot of textures in the scene, and the scene itself isn't that big. So the memory is not nearly maxed out at all. But our CPU, which is what rendering is really intensive on, is all of our cores here are at 100%. Now when you're comparing the two systems, our in-house system compared to the DataBrick system, we have a 2.7 gigahertz 16-core system, and they have the 2.3 gigahertz 12-core system. And for this system being only 5 minutes slower than our system, you would have thought that there would have been a much larger gap. But because of the architecture of the system and the way they have things built out in here, they've managed to, with a lower gigahertz and with actually fewer cores, pretty much match the speed of our in-house built systems. Now the next thing we're going to do is take this exact same image and re-render it again using the V-Ray shaders and the V-Ray renderer, and then one more time we're going to re-render this image turning on the CUDA core processors in the Tesla card and seeing what the CPU versus the GPU render, and see what kind of time we can save using that architecture. Let me just show you how fast the RAID system in the DataBrick NLE really is. Here it is. We have a scene. Yes, it's 2 million and some odd faces, and we have only a few objects in here, but as soon as I go to File, I'm going to open Recent. I'm going to go to my V-Ray scene here. And no, we don't need to save that. Look at that. It opened up that scene in a blink of an eye. There was no loading. There was nothing. In fact, I couldn't even tell you what kind of a fraction of a second. We're in a completely different scene right now, completely different settings. Plugins that weren't turned on in the other one are now turned on in this one. And it read that scene in under a second. That was real time. There was no edit. There was nothing there. That was just go in File and open it. Just to show you again, I can go File, open Recent, and go back to the other scene. And no, don't save. And again, bam, we're there. It's just really, really fast. We've done this with much larger scenes, and again, the RAID system on here is actually really, really good. It reads data from the hard drive at lightning speed. All right, so we just finished rendering in the V-Ray using the Tesla card on the DataBrick system. Originally, when we rendered this scene out at the Sphere with their computer systems, we took 30 minutes to render the frame. Here, using just the CPUs, mind you, we're using only 12 cores here versus 16 cores. It took 35 minutes. But once we were able to enable the Tesla card, we cut that 35 minutes down to a drastic 10 minutes. Actually, 9 minutes and 57 seconds to be exact. It's 3 times faster. It's amazing. I can only imagine on a long animation or any type of rendering, any type of project that needs to be done in 3D, anything that can cut your time down by a third, that's just money in the bank, which is very, very impressive.